so we are going to discuss current affairs of science and technology. What is this?
Sir, add with us.
Okay, so current affairs of science and technology. This portion obviously is very scattered. In this case, it's we'll be taking up issues, okay, and don't expect too much of continuity over there. I can't help it. That's not my problem. It's the problem of the subject. So first to start with, I am expecting a question 99%. Obviously, that's my analysis. I will be happy if I have proved right. That is Quest. Okay, so Quest is obviously a Chinese satellite. I will dictate. Just listen, because here we can't do this thing simultaneously. You need to understand. All of you have read it a lot. First understand. And if we need one extra day, there is no problem. But we should be able to solve the question. Quest. Actually, this is the first quantum satellite which has been launched. Obviously, it has been done by China. Okay, fine. What type of satellite it is? Remote sensing or telecommunication? In which orbit it has been placed? This is what question I am going to ask in preliminary. It has been placed in 500 kilometer orbit from the surface of Earth. And if it is 500 kilometer from the surface of Earth, that is what we call as low Earth orbit. Low Earth orbit. Okay, fine. Now, what is the principle it is using? The principle on which this satellite is based is known as entanglement. Remember this word, entanglement. This is the heart and soul of the quantum communication satellite. What is entanglement? Those people who have already done the classes, I think I might have discussed this thing with you. And again, what is entanglement? Actually, entanglement is a very fundamental principle of quantum physics. Okay, quantum physics, something which deals with the behavior of individual atom, molecule, photon, proton, electron, etc., etc., etc. That is what we call as quantum physics. But exactly what is entanglement? Actually, in entanglement, what they do? Listen here. Don't change your posture. In entanglement, they bring two quantum entities close to each other, and after bringing close to each other, a sort of parity is established. Parity. What is the meaning parity? Like if you will influence one, that will have a direct bearing on the other. On other meaning of the parity is, if you know this electron is up, then automatically it should imply the other one will be in the state of down. If you know this one is moving in a clockwise direction, then you don't have to look at the other one, that it will be automatically moving in the anti-clockwise direction. That is known as entanglement. Is this clear? Okay. Now entanglement, where he will trap you. If he wants to bring down cutoff to 25, then this is the line he will be using in one of the sentences. Like entanglement can only be demonstrated at the nano scale. No. Once this entanglement, this parity is established, you can separate them to any distance, any distance. Previously, entanglement, they were able to demonstrate up to the distance of 300 kilometers, means once they are paired, this was 300 kilometers this side and 300 kilometers. Now, they are looking to it somewhere around 1500 to 1200 kilometer distance. Okay, what's the USP of this satellite? This satellite is the first one of this nature. No, it's not a complete project of China. This is a joint venture of China and Austria. Okay, that is Austria is also involved over there. Now, what exactly their thing is, like it will be like from that satellite, this is say for example an entangled pair. One part of this pair will be sent to Urumqi. Urumqi, where it is? Xinjiang Uyghur Autonomous Region, and which is obviously a troubled part as far as China is concerned, and other will be coming down to Beijing. Okay, then obviously you can imagine they are going to be hundreds of kilometers apart. That is the quantum satellite. But okay, although it is not a good sign for us, because if China is having quantum communication technology, that means they are very close to have the quantum computers also. And if they are having quantum computers, then none of our database is safe. Okay, the security, cyber security of our systems, which is based on conventional coding and all, by using quantum computers, it could be disrupted or broken down like anything. No comparison between the two, but obviously that's we'll leave it over here itself. Okay, just one more point you need to remember, that entanglement leads to the state of superposition. Superposition means existing in two states simultaneously, clockwise as well as anti-clockwise. And just one more point I'd like to add over here, that the capacity is expressed in qubits, that is the quantum bits of the quantum computers. But in case of this satellite, I don't think the examiner will be going too far. He will be focusing mostly on that satellite. You just need to know the name of that satellite. In Chinese, this is Micius, M-I-C-I-U-S, which is the name of a Chinese god, okay, for that purpose. And obviously, it will be using the principle of entanglement. That is also called as quantum teleportation, okay. And obviously, what is the other point? It is very difficult to hack such systems, okay. And one more thing which we will remember, that this thing, entanglement, could be demonstrated for any distance. Any distance means any distance, okay. These are 3-4 points. We need to be very specific. We can't solve the questions by being generic. Oh yes, China has launched the satellite, and after seeing the options, we are like, why have not studied in detail? Okay, so that will not help our cause. Now, next part after this is another prominent area of question, which again is this. I'm having my list actually, just to see what all. Yes, this thing. There is a program of NASA. That is the second topic. I'll dictate, don't worry. That program is known as New Frontiers Program. And it is in news like anything. New Frontiers Program is not one program, rather it includes multiple programs. And obviously in New Frontiers, they have, as of now, conducted 3 programs. First is known as New Horizons. New Horizons is for studying Pluto. And obviously one more thing, Pluto lies in something known as Kuiper Belt. Kuiper Belt lies beyond Neptune. Okay, and what is the USP of Kuiper Belt? In this case, icy rocky materials are there, icy and rocky, because it is so far from sun, the temperature will keep on declining, and obviously as a result, the formation will be icy. And the biggest object in the Kuiper Belt is expected to be Pluto. Okay, so that is New Horizons program for you. After New Horizons program, there is one more, Juno. Juno is also a part of New Frontier program. Okay, now obviously here, Juno is a Greek goddess for Jupiter. Okay, and Jupiter obviously is a planet. Why they have named it Juno? Just it will help you in remembering this. According to Greek mythology, Jupiter was always a mischievous god for them. And obviously it will hide behind the clouds. But Juno, the wife, now you know this thing, will always be able to find out behind the cloud that who is actually doing the mischievous things. Okay, that way. So obviously Juno, why it has been named as Mission Juno? Reason being that this mission will be able to study Jupiter even if there are dark clouds covering or surrounding that planet. That's anecdote I have said so that you can remember this thing. Okay, that clouds are not going to hamper the operation of Juno. What exactly Juno will study? Juno will study the process of the formation of the Jupiter, solar system, and obviously whether obviously any life existed over there or not. That's one part. Just one more mission. Just one. Like just one confusion point. There is one more mission known as Europa. Now Europa is not of Europe. No. Europa is also of NASA. So how Europa differs from Juno? Europa is a moon of Jupiter. And this Europa will study that moon, this Europa will study that, and this mission is known as Clipper. Clipper means what? It will not be orbiting permanently around that. It will come, touch, go. It will come, touch, and go. And what it is looking to study, that actually on Europa, there is a possibility of liquid water. And if liquid water is there and that liquid water is then broken down by the sunlight, then obviously this is how life originated on Earth in those times. So obviously Europa is an astrobiology mission, whereas Juno is not an astrobiology mission. Juno is simply there to study the process of the formation of what we call as Jupiter. So you will not take astrobiology option as far as Juno is concerned.
But it will also take life.
No. It is like a passive aspect. It will not search for the presence of life. When it is looking to search for the presence of life, that is what we call as astrobiology. Isn't it? Whether life is there or not, whether life was there or not, that is not astrobiology. Okay. Then just in that part as well, the third mission, which is again you have read, is Osiris Rex. Osiris Rex, how it is different from the other two?
Asteroid.
It will be studying Bennu, B-E-N-N-U. And Bennu is what? Is a near-Earth asteroid. And near-Earth asteroid, what is the USP of Osiris Rex? The Osiris Rex USP is that it will be landing over there in 2 years' time, take the sample of the rock and come back. Okay, so it is a sample return mission as far as the asteroid is concerned, that is the Osiris Rex. No marks for guessing, it is a mission of NASA. All the four which I have mentioned over here, they are the missions of NASA. Okay, now you please take down.
Near-Earth asteroid is called as elusive asteroid.
Elusive in terms of like it's not, there is no scientific reason for that. It's just like there is a bit of you can say lack of clarity. That's why they call as lack of clarity in terms of their behavior and the properties and all that. Okay, fine. Take down QUESS, Q-U-E-S-S. That is quantum experiment at space scale. Quantum experiment at space scale. Also known as MISSIUS, M-I-C-I-U-S, MISSIUS. It is the world's first. It is the world's first quantum communication satellite. Quantum communication satellite. It will be using the principle of entanglement. It will be using the principle of entanglement. Entanglement, quote unquote. Entanglement is a unique behavior. Entanglement is a unique behavior of quantum particles quantum particles it is like establishing a parity. It is like establishing a parity, between the two particles and by looking at the one and by looking at the one, the state of the other, by looking at the one, the state of the other could be easily predicted. Could be easily predicted. Once the entanglement is established, once the entanglement will be established, the paired particles, I am again saying, remember this line, the paired particles could be, no, quantum only.
So how can electrons or protons or quantum particles operate?
No, they will not be operating. Here they have used, in this case, they are using photons. Are you getting more? They have not used electrons. And photons are light bundles. Is it? Okay. So obviously these photons and they are bosons, they will be having their spin, and the value of their spin is an integral, if you can recall the previous classes we had. So what they will do, they will be using a laser. Okay, with the help of these lasers, the paired photons, which are in entangled state, one will be brought at location A, other will be brought at location B. This is what they are looking to demonstrate now. Yes. All of them will be in that particular state. Okay, now got it? Okay, where I was? Will you, once the entangled particle, once the entanglement will be established, the paired particles could be separated for any distance, without disturbing the unique arrangement, Previously, entanglement was demonstrated for a distance of 300 km. Previously, entanglement was demonstrated for a distance of 300 km. Now China is looking to carry out entanglement at a distance of 1200 kilometer. 1200 kilometer. Continue further. Just one more line without. The USP of quantum communication is that such systems are virtually hack proof. Full stop. Next you can write, obviously we can keep on writing. Austria and China. Austria. They are partner in this program.
already said that this is a joint venture of that is the right step.
No, it is not a joint venture. They are a minor partner in that. Main is China. Okay. Next is New Frontiers program of NASA. New Frontiers. हाँ? वो नहीं हो पाएगा. ये तो एक नेचुरल आदत वो जो होती है ना वो. अच्छा ठीक है. ठीक है. Okay. So, New Frontiers program of NASA. As of now, 3 missions of this program, as of now, 3 missions of this program have been carried out. First, New Horizon program, New Horizon mission for Pluto, and other objects in Kuiper belt. Kuiper belt lies beyond Neptune. That is 30 astronomical unit to 55 astronomical unit. 30 astronomical unit to 55 astronomical unit. This is the range of Kuiper belt. In this region, mostly the objects are icy and rocky. Among them, the biggest is Pluto. The biggest is Pluto. And for Pluto, the biggest moon of Pluto is Charon. Newspaper, same article, Charon. So it's a moon of Pluto. This is enough. Next, Osiris Rex. First take down the full form. Origins, Osiris Rex, OSIRIS, origin, spectral interpretation, resource identification, security, regolith explorer, regolith, REGOLITH, regolith explorer. It is a sample return mission. For near Earth asteroid, Bennu, 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 BENNU. Bennu. It will be landing the asteroid in 2018. It will be landing on the asteroid in 2018 and will return to Earth by 2023. Will return to Earth by 2023. Can you give me the name of some other sample return mission? Come on. Chang'e 5, China. Phobos Grunt. Whom? Come on. Those people who have attended the classes, please have eye contact. And feel a bit of guilt. Phobos Grunt of Russia. Phobos is one of the moon of Mars. Okay, what happened to Phobos Grunt? Failed. Lander was failed. Okay, so if they say no, like just like what I'm trying to specify, again I will say this point. We need to be very specific. Less number of points, but those points will be very specific. It should not be generic. Phobos Grunt, one of the moon for Mars. Obviously, we know that asteroid is also between Mars and Jupiter. So we'll get confused. No, we don't have to get confused. Chang'e 5 sample return moon mission for moon. Obviously, it has to happen in 2017. That's why a very probable area of the question is. So I hope now know what is the status of Phobos Grunt. Failed. What is the status? This one is on the way. We don't know whether it will be, because it is yet to reach there. And obviously China is yet to launch that. So obviously if they say, like, very simple point, the sample return mission has been demonstrated. No. Okay. Like that way you need to be very clear with it. Okay, fine. Now come to Juno. Juno is a Jupiter mission of NASA. Juno is a Jupiter mission of NASA. It was launched in 2011. It is a flyby. Must remember this. Flyby. What is flyby? Means it will not be following a particular path. It is a flyby. That means it will not be continuously orbiting. It will not be continuously orbiting the planet, but it will return after regular intervals. It will return after regular intervals. Juno as per Greek mythology was the wife of Jupiter. This mission can observe Jupiter despite the presence of clouds. Remember this line. Despite the presence of cloud. Full stop. It will study the atmosphere, comma, lights around north and south pole of Jupiter, north and south pole of Jupiter, comma, how Jupiter has changed over a period of time, Next, Europa Clipper. Europa Clipper.
This is
No, it is not the first one, but it is the first to reach Jupiter.
Earlier, the Galileo could not reach.
Galileo was there, but obviously this is the first to perform this type of activities. It was simple observation, it is detailed observation. Okay, now take down. Europa Clipper, just 2-3 lines. Europa Clipper is a mission of NASA. Europa Clipper is a mission of NASA. Europa Clipper is a mission of NASA. It is for studying Europa, a moon of Jupiter, a moon of Jupiter. It is an astrobiology mission. It is an astrobiology mission as it is looking for the presence of life, because on the surface of Europa, liquid water is present. At the same time, it continuously receives highly energetic solar radiations, It is expected that the water molecules could have been broken down by the sun rays, providing the possibilities for the existence of conditions necessary for the origin of life. I hope now difference is clear, okay, among all this. Now, after this, we will be talking about okay, where I was. Okay, just listen. That is CIRB Gaurav. All of you have read about it. Okay. CIRB Gaurav is a cloned buffalo. Who has done it? Central Institute of Research on Buffaloes, where it is Hisar. Is it the first instance of the cloning of a mammal in India? No, Garima 1 and Garima 2. Garima 1 and Garima 2 were cloned by whom? National Dairy Research Institute, Karnal. That's a separate setup. This is a separate setup. Okay. Now, what is the USP of CIRB Gaurav? First and foremost, it is a part of the project of the Government of India, conservation for the conservation and manipulation of the germplasm of buffaloes. Okay, as a part of this has been executed. And how it is different? actually is a worst case type of a question. This is for the first time a cloning has been carried out by using the cell from the ventral side of the tail of the male bull. Why they have used the ventral side of the cell from the tail of a male bull is that ventral side means not exposed to solar radiations. And when it is not exposed to solar radiation, the possibility of the changes being introduced in the genetic makeup is virtually negligible. This means the mutations will not be there. Okay, fine. This is the first time. This is the USP of this particular CIRB Gaurav. Okay, fine. Now again, listen here. What is the method actually they have used? The method they actually use is known as hand-guided cloning method. Again, obviously this is not the time to discuss all these things in detail. I will just give you brief. Okay, don't use somatic cell nuclear transfer, because Dolly is also a possible area of question, because Dolly would have been 20 this year because it was cloned in 97. So, and UPSC is very fond of anniversaries and dates. I'm telling you. Okay, although unfortunately she is not around. So that's what was the method used in the case of Dolly? Somatic cell nuclear transfer. What is the difference? Just I will not dictate, just listen, I'll give you opportunity. In hand-guided cloning method, they take somatic cells, some of you might have forgot. They take one ovum. Okay, then this ovum the nucleus is removed by cutting down, and this cell is fused. Then there is a blastocyst, and then this blastocyst is transferred in the womb of a surrogate mother. In this case, actually, this cell was taken from a different buffalo, ovum was taken from a different buffalo, and womb was taken from a different buffalo. So there were 3 involved, not one buffalo. Okay. Same thing was done, cloning was done in case of Dolly as well. Here they take one somatic cell. Okay. Then there is one ovum. The nucleus is removed. Okay. Then this nucleus is transferred here. Getting it? So just as I said those times as well, now I'm saying today, just see the difference. The difference between the two lies how the chromosomes are being completed. In this case, fusing the somatic cell with the enucleated ovum. In this case, transferring only the nucleus. Is this clear? I have to go a bit fast over here. Then there is formation of blastocyst, and then this blastocyst is transferred from in the womb. Okay. This was from sheep 1, this was from sheep 2, and this was from sheep 3. So here it is S1, S2, S3, there it was B1, B2, B3. Just simple, again worst case, same, no. All the 3 from different sheeps or from different buffaloes. This is how Gaurav was done, hand-guided cloning method. This is how Dolly was done. Again, just last point. This is the 3rd instance of the cloning of buffalo in the world. And obviously, out of that, 1st and 3rd has been in India. 2nd is somewhere else. Okay, that I have not got the answer. I tried to search for it, but didn't got the answer. Okay, I don't think they will be asking this. This is CIRB Gaurav. I hope it's fine. Now listen, just one more. Again, lot in news. For some of you, it might be repetition. For some of you, those previous batch. Current batch, this won't be the repetition. So like there is like 1st January 2017. I know you people might not be in a mood to study at that time. And that too obviously 1st January, that too Sunday. And then to obviously read such articles, that's not the priority. Okay. But obviously, what's the actually page number? I don't remember, date I remember. Sin 1.0 and Sin 3.0. Just a brief part. Why it was in news? What exactly here? What he will ask? The implications of this research. Let me start the implication of this research. There is a company, very well-known organization. Some of you might have even done the internship with them. ExxonMobil. EXXON. Okay, if you have not, then no problem. Okay, now listen here. This company has funded this project. Why they are funding this project? That's, if you can remember this anecdote, then your job is done. The purpose of this project is to have the bacteria. What? Bacteria. What they will do? These bacteria will take up the atmospheric oxygen and convert that atmospheric oxygen into biofuel. Just imagine, obviously, the implications. Obviously, it is going to be $1 trillion industry, not even $1 billion of industry. For this purpose, obviously, there are other aspects also that we will see. So what exactly SIN 1.0 and SIN 3.0? For some of you, it is a repetition, but again, I'm not doing old things, I'm doing the current part. Okay, it was in news like anything, and I don't know why they have not asked this question till now. Okay, at times UPSC is very inexplicable that you don't really understand. So what is like, this project is started in 2010, not started in 2010. This was in 2010, they announced they have synthesized world's first cell, synthesized cell. Okay, and what is the name of the organization? JCVI, J. Craig Venter Institute. And this organization is very, very rich. They have carried out human genome project at their own. That was funded by the government of US. So you can imagine they're not some small poor type of organization. What they did exactly? They took a bacteria, and the name of the bacteria was Mycoplasma. Come on, mycoides. So mycoides. What they did, listen, don't write. फिर मैं नहीं dictate करता हूँ. आप लोग लिखना है तो. फिर we'll be able to do it today itself. But I don't want. Mycoplasma mycoides. What they did, they copied the genome of this bacteria. What? Copied the genome of this bacteria. They didn't use it. They used it, but obviously made the same type of genome in the lab. Okay. Then they took another bacteria, obviously Mycoplasma capricolum. You need to remember the name. Spellings. Yes, I will give the spelling. Capricolum. This genome which they synthesized, don't get confused, was having 1.08 million base pairs. Okay, but the genes were somewhere 970 odd. Okay, to be very precise, obviously 971 genes were there. They transferred this genome in this bacteria after removing its genome, Mycoplasma capricolum. And what they found, that this bacteria was still dividing. This is very much like organ transplantation in human beings. But here they were transplanting the genome. This was named as world's first synthetic cell. It was named as Mycoplasma mycoides, JCVI, name of the organization, SIN SYN 1.0. Is it okay? That is SIN 1.0. When people asked Mr. Craig Venter, the head of this body, sir, what exactly you're looking to do? Now listen here. The first thing he said, we are looking to work on the concept of minimal genome. Minimal genome. What is the concept of minimal genome? He said we will take out this again and deduct some genes. Again transfer it in the bacteria. We'll see whether bacteria is still dividing or not. If it is still dividing, we'll further take out it. Like say for example, next time 2 they have eliminated, so 969 genes. Then again they will remove some genes. So this, at one point of time, the bacteria will stop dividing. Are you getting mine? That means a gene above that is the minimum number of genes required for the bacteria to survive. Is this clear? That has been named as minimal genome. And what is the implication? Again, remember implication. Minimal genome is not implication. Is it okay? Minimal genome is not the implication. Here they want to understand the process of evolution. That how as the number of genes increases, the life forms gets that much more complicated. And this is where they have achieved this thing last year. Mycoplasma capricolum, they kept on reducing the number of genes. And when the number of genes came down to 473, to be precise, at that level, this bacteria stopped dividing, and that has been named as SYN 3.0. Okay, so SYN 3.0, what is that? Till date, This is the organism which is having the minimum number of genes ever counted. Okay, that is, I hope it's okay, fine. What all, well, like, then some of you might be having said, what about Sin 2.0? Why you have left that out? Actually, I haven't left it out. Sin 2.0 was an intermediate between the two. So you can say it is more of a transition, more of a flux type of a thing, rather than something concrete. What they are looking? Biofuel. You will not rule out. What they are looking? Vaccines. What they are looking at? Removal of the pollutants, but at the same time, biological weapons also. Okay, so that is what obviously Sin 1.0 and Sin 3.0 are all about. Fine. So what these 3-4 things you need to remember: minimal genome linked. If they will not give minimal genome and they say evolutionary biology, that also you are going to take as the correct option over there. Is this clear? Okay, now please take down. CIRB Gaurav. CIRB Gaurav. Central Institute for Research on Buffaloes, Hisar. Central Institute for Research on Buffaloes, Hisar. Central Institute for Research on Buffaloes, Hisar, has carried out second cloning of buffalo in the country. Second cloning of buffalo in the country. First one was of Garima. First one was of Garima. First one was of Garima. That was carried out by National Dairy Research Institute. National Dairy Research Institute. Where? Karnal. So it is not same organization. National Dairy Research Institute, Karnal. The method used was hand-guided cloning. The method used was hand-guided cloning. Hand-guided cloning. Hand-guided cloning. Whereas in case of Dolly, the technique was, somatic cell nuclear transfer. Full stop. CIRB Gaurav is cloned. CIRB Gaurav is cloned under the program conservation and manipulation. Conservation and manipulation, quote unquote, this entire program, manipulation of the germplasm of buffaloes. Germplasm of buffaloes. This cloning is different because very important point, because for the first time, cells were used. What type of cell? No marks for guessing. Somatic cell. Okay. Cells were used from the ventral side. Cells were used from the ventral side of the tail of male buffalo. Tail of male buffalo. These cells were preferred. These cells were preferred because they are least exposed to solar radiations. They are least exposed to solar radiation. Therefore, the chances of them undergoing genetic changes are almost negligible. Full stop. CIRB Gaurav. Okay, that is the heading. Next time, next topic, SIN 1.0 and SIN 3.0. SIN 1.0 and SIN 3.0. In 2010, J. Craig Venter Institute, I'm writing over here, J. Craig Venter Institute announced that they have developed world's first synthetic cell, Mycoplasma mycoides, JCVI, J for Jaipur, C for Coimbatore, JCVI, SIN 1.0. SIN 1.0. They took two bacteria. Okay. They took two bacteria, Mycoplasma and they took two bacteria, Mycoplasma mycoides, and Mycoplasma capriculum, They took the genome of the former means mycoides, and copied it with some modifications it was having 1.08 million base pairs. It was having 1.08 million base pairs, right in bracket, 971 genes. The synthesized genome the synthesized genome was transferred in Mycoplasma capricolum. In Mycoplasma capricolum, and it was still dividing. It was still dividing. It was described as world's first synthetic cell. World's first synthetic cell. One of the objectives of the research was to find out minimal genome that is the minimum number of genes required, for the cell to survive. That will have the implications for understanding evolutionary process must be there at PT point of view. Remember these two words, you will get the question. Evolutionary process. Under evolutionary biology. As a part of this program, they synthesized a genome with just 473 genes. And if you see, it is less than half, 971, 473. 473 genes. And that genome was transferred where? Same bacteria, Mycoplasma, and that genome was transferred in Mycoplasma capricolum. Mycoplasma capricolum, named as SYN 3.0, SYN 3.0. Full stop. The implications, other implications are biofuel production, comma, ExxonMobil, EXXON, ExxonMobil has funded a part of the research. ExxonMobil has funded a part of the research, The purpose is to have bacteria the purpose is to have bacteria capable of converting atmospheric carbon dioxide in biofuel. Atmospheric carbon dioxide, oxygen, how come it, what I said? No. Carbon dioxide. Oxygen biofuel कैसे बन जाएगा? Huh? Okay. Capable of converting carbon dioxide in biofuel. Carbon dioxide in biofuel. Second, it will also be useful in developing vaccines and developing bacteria for the removal of pollutants. That is known as bioremediation. Full stop. Next. Huh? What?
My brother is coming to Saturday, so I want to go to visit him.
Okay. You.
Sir?
Hmm.
So when you were talking about this genome transfer, talking about this plasmid or the bacterial chromosome?
Obviously, we are talking about bacterial chromosome, not the plasma. Okay, please listen. Where I was. Okay. Next part. Next is GM mosquito. Where the trials have started. Come on. Where trial has started? Jalna. Where is Jalna? Maharashtra. Obviously, what's the purpose? Obviously, dengue and chikungunya. Okay. What exactly? Actually, there are two things in the same article which you have read in Hindu, which I am elaborating here. You have read one part of that article was about GM mosquito. Other was about the use of a bacteria Wolbachia. Listen here. This first I will start with this. If a mosquito or insect is having this bacteria, then it does not allow the growth of virus in that mosquito. Getting it? But the problem is that mosquito, which one? Aedes aegypti. That is a different thing. This bacteria is not found in this mosquito. So there are two approaches which are being worked on. One is case of GM mosquito. Other is infecting Aedes aegypti with this bacteria so that mosquito will be alive, which is obviously a part of biodiversity. But in that mosquito, that virus which causes dengue or chikungunya will not grow. So even if it will bite human beings, obviously that will be only a temporary issue, but not the permanent issue. That will be the case. Okay. But first I will talk about GM mosquito. GM mosquito, there is one international organization known as Oxitac. They are the one who have started this, and they have brought these GM mosquitoes in cages from abroad. In this case, what they have done, here you will find that 4 alphabets RIDL, releasing insect with dominant lethal genes. Dominant lethal. You know the meaning of the both. So what they did, they took male mosquito. Okay, and these male mosquitoes were transferred with this gene. Okay, is it okay? So that is genetically modified mosquito. Next step is these mosquitoes will be released in the environment. And when they will be released in the environment, they will be mating with the wild, obviously, female mosquitoes of the same variety, Aedes aegypti. But what will happen when the mating will happen? Don't you think this gene from this mosquito will be meeting with the genes of that female? Because of these genes, what will happen? The eggs will be there, but those eggs will be killed at the level of the larva itself. So the mosquito will not develop from those eggs with the larva. That is known as GM mosquitoes, where it will be in male mosquito. Female mosquito will not be genetically modified. Again, I am specifying things. Mating will happen. Then what will happen? The mosquitoes will be killed at the level of the larva itself. But what's the problem here? These mosquitoes will not be there in environment forever, eternity. I hope you got the point with them. So at regular intervals, you have to keep on releasing such mosquitoes in the environment. And that's where the question of sustainability comes. In trial phase, they may do well. But obviously, when the question in nature, obviously, it's not like, okay, fine, where are you going? I'm going to buy GM mosquito. Khatam ho gaya. So that obviously, that has to be done naturally. And that's where it is not. I hope you will not miss the point, which I'm trying to make. People are saying, this is a better approach. How it is a better approach? What will happen? In this case, that you will, if you will infect a male mosquito with Wolbachia, and if that male mosquito will mate with a mosquito without Wolbachia, what is Wolbachia? A bacteria. Then obviously mating will happen, but there will be no mosquito. That's good. And in case you will say, sir, what is vice versa? If a female, I hope this point is okay, then the problem will be stopped there itself. And the another case is, in case you infect female mosquito with Wolbachia and male mosquito is uninfected, in that case mating will be there. In that case, what will happen? That what we say, the mosquito, the larva will develop into mosquito. But what's the problem? What's the benefit over it? Not the problem. Those male mosquitoes and the female mosquitoes all will have that Wolbachia. Are you getting my point? That means it will be transferred from one generation to another generation. So obviously, this is more in accordance with the ethos of biodiversity, if you see. That's one point. So this will be self-sustaining. That will be self-limiting. These two words, 4 words you will find. In case of GM mosquito, self-limiting. Why? Because once that generation will be killed, you have to supply it. Here, obviously, it will be passed on from generation to generation. Okay, and now you will say, sir, why that in first case? It will not be the case because that is what we call as cytoplasmic incompatibility. Worst case scenario. What is cytoplasmic incompatibility? In that case, that bacteria induces some changes in the gametes and they become incompatible. Incompatible means the fertilization will not take place. Is it okay? This is Wolbachia approach and that is GM. This is self-limiting. This is self-sustaining. Okay, here what the bacteria does, kills the virus. Here what happened? Larva does not grow into full-fledged mosquito. In fact, male with the RIDL. Research has been started for this. This is still in the form of research papers. You get it? But obviously, in my opinion, this is always a better approach than this. Okay, fine. Got it? Take down. GM mosquito. GM mosquito. The research have, sorry, the field trials. The field trials have started. Field trials have started. Okay. Field trials have started in Jalna district of Maharashtra. Jalna. Jalna district of Maharashtra. The male Aedes aegypti, the male Aedes, A-E-D-E-S, aegypti, was infected, was genetically modified, not infected, was genetically modified. This is known as release of insects, release of insects with dominant lethal genes. Release of insects with dominant lethal genes. When such genetically modified mosquitoes are released in nature, they will be mating, M-A-T-I-N-G. They will be mating the wild female mosquitoes, but the larvae will fail to evolve in mosquito, The criticism of RIDL approach, 4 alphabets you have to remember. The criticism of RIDL, whether I have given the full form? Okay. The criticism of RIDL approach is it is self-limiting. It is self-limiting, quote unquote, because there has to be continuous release of GM male mosquitoes, in the environment. Full stop. Another approach, next paragraph, another approach which is being seriously deliberated is the use of bacteria, Wolbachia, spelling is here, W-O-L-B-A-C-H-I-A, Wolbachia. Naturally, this bacteria inhibits the growth of virus. Naturally, this bacteria inhibits the growth of virus. But It is not found in Aedes aegypti, but it is not found in Aedes aegypti. Aedes aegypti. Okay, Aedes aegypti. Full stop. If a male mosquito infected with Wolbachia mates with wild female mosquitoes, they are unable to reproduce. They are unable to reproduce because of cytoplasmic incompatibility. Cytoplasmic, CYTO, cytoplasmic incompatibility. On the contrary, female mosquitoes infected by the bacteria will produce surviving embryos, irrespective of the fact whether male is infected or non-infected. Male is infected or non-infected. Full stop. Next, you can, before I forget, is like last year they asked a question on transcriptome. This was a question. This year they may ask a question on Yamanaka genes. Why? Because it is linked to one of the Nobel Prizes. That's why I'm discussing. It's not a research paper. Biotech people shall we continue? Here I know it's very difficult for you to continue the things because topics keeps on changing very abruptly, and that's the nature of current affairs. So like Yamanaka genes, just remember one thing, like what type of question they will be framing. First and foremost, what is their contribution? Their contribution lies in something known as iPSC. That again I have discussed with some of you, but not all of you. Induced pluripotent stem cells. And what is the utility of induced pluripotent stem cells? You can convert a normal cell into a stem cell. Okay. If you can remember these 2 points, you have done your job. But obviously, like Yamanaka genes, basically, they are 4 genes. Also known as OSKM. Worst case scenario. These 4 alphabets you need to remember. Okay, fine. What happened actually in 2011 or 12, the Nobel Prize was given to Shinya Yamanaka and John Gurdon. What they did, they used these genes because there is something known as stem cell research. And biotech people will agree with me, stem cell research is highly controversial. Anything in biotechnology is controversial. Because you see, every area is having some or the other controversy. Okay, so same is the case over here. So the problem was that they don't want to use embryonic stem cells. Embryonic means obtained from the blastocysts. So what they did, they took a skin cell and identified these 4 genes, and by controlling these 4 genes, they were able to convert this skin cell into stem cell. A skin cell is a specialized cell. Means whenever it will divide, it will form only a skin cell. But stem cell is unspecialized cell. Means as per the need, you can give it any direction. Lung, retina, heart, kidney, whatever you want, you can have it. That is known as induced pluripotent stem cells, transforming a specialized cell into an unspecialized somatic cells. And for that transformation, they used 4 genes, and those 4 genes, otherwise they are expressed as OSKM, and recently they have been named as Yamanaka genes. Is this clear? What is one more implication part? Here obviously there is something known as therapeutic cloning. Therapeutic cloning means what? In lab we are looking to have the organs. There are some examples you keep on reading here and there, that they have transformed this cell into that cell. Okay, that is what we're looking at, therapeutic cloning, and obviously without requiring embryonic stem cells. So obviously ethical debate will also not be there. At the same time, your purpose will be served, and that is what we call as Yamanaka genes. Right? अच्छा बैटरी चेंज करना है. Okay, now just okay, ठीक है. I hope there is you're finding bit of a relevance of the things. If you don't find it, please raise the hand. So obviously, and give the reasons also, because the purpose should be served. That's most important, because this is a very critical time and you people are really brave coming to the class at this juncture. Okay. So I don't want that you should feel like, oh, मैं क्यों आया? मुझे नहीं आना चाहिए था. That should not be the case. If you feel like, okay, next part, please listen. LIGO India, where it is coming up? India, फिर इंडिया ही बोल दो. महाराष्ट्र में कहाँ? Where? Hingoli district. Maharashtra people should at least answer this. Hingoli district. A specific place on AUNDH. I will be asking one simple question if I get the opportunity to frame the question. Which particular agency of government of India is involved in the implementation of this project? Department of Atomic Energy. Along with whom? National Science Foundation of US. Remember this. Again, same point, specification. LIGO, obviously, what is the operating principle of LIGO? Laser Interferometer Gravitational Wave Observatory. Where else these LIGOs are? Come on. Those who have attended the class last year. Louisiana, Livingstone, Hanford, Washington, Germany, Japan, Italy, and obviously next. But if you see, along with National Science Foundation, it is the first outside US. Please see the language of that. Those are not the involvement of the National Science Foundation of US. Just a brief introduction to gravitational waves. I will not be spending too much of a time. The concept was given by one person, okay, Albert Einstein in 1915. Okay, detected on when they were detected? 15 September 2000. Where? 14? Okay, that's where you see exact, no 15. It was like 14 September 2015. And that is exact 100 years later. What exactly gravitational wave is? Like just, I'll give you an analogy. It is like this. Say for example, you are holding an iron ball, say this big solid ball. And those people sitting at the back of the class, those sitting in the middle and those sitting in the front. And you are standing here. and you have simply dropped that ball, what will happen? You will feel those vibrations, isn't it? Those vibrations are gravitational waves. So they are the distortions created in the space-time because of some cataclysmic event, huge. Just again here, the observable means something which we can feel. Gravitational waves are because of some massive thing. But you know what? As per the theory, when these two markers are being moved like this, they are also producing gravitational waves. But their mass is compared to those black holes. One was having mass 36 times the mass of a sun, and the other was having mass 29 times the mass of a sun. And when they were spiraling around, you can imagine the momentum. And when they simply had that booming sound, 6 times the energy of which is equal to the mass of sun was released in the form of energy. 6 solar masses were released in the form of energy. Just imagine the vibrations that will cause. Those vibrations were felt on 14 September 2015, where Hanford and Lucia by LIGO. Is this clear? So that is what we call as gravitational waves. Just brief. So any two mass, yes. Observable, it has to be huge. What will be the relevance of gravitational waves? The relevance of gravitational waves where your Hubble or James Webb will fail is that they will not use any electromagnetic radiation. And when they will not use electromagnetic radiation, they will help us in understanding something known as black holes. Because black holes, you can't use infrared, ultraviolet, microwave because they will not allow that to come back. And when they will not allow it to come back, obviously you will not receive any information. And when you will not receive any information, obviously nothing is going to happen. This is what's the utility. Just one more point. Electromagnetic and gravitational, as I've discussed in the previous classes, they are always going, gravitational waves are always going to be weaker than the electromagnetic radiation. That's simple. That if you like, it is very much like this. Piece of iron on the surface of Earth, magnet, it will pull upwards. That means electromagnetic is stronger than the gravitational. Otherwise, those pieces would never have come upwards. So, but just brief. LIGO. What is LIGO? It is an L-shaped structure. Are we going to follow the same model as it is there in Hanford? Yes. Exactly same approach. What is the operating principle of LIGO? I hope I'm not going too fast. The operating principle of LIGO is interference. That is why interferometer gravitational wave observatory. What they are looking, obviously, in Hingoli, what they will do, they will have two L-shaped arms this way. Each will have exact same length, 4 kilometers. This is the same thing which is there in LIGOs over there. Fine. They are going to have the mirrors at the ends, M1 and M2. Okay. Then there is a source of laser over here. And then there will be a beam splitter. Beam. It will split that beam. Okay. Same thing. I'm just repeating it, consolidating it because there are some fresh faces also. Laser will be released, and laser will be released in such a way that there is a destructive interference. Destructive, not constructive. Constructive will not serve the purpose. Okay. So it will split. One wave will go in this direction, other will go in this direction. What will happen? As the length has to be same. If length is not same, it will not give you the result. That's why 4 kilometer, 4 kilometer. Measured to the level of angstrom. Okay, it's not broadly 4.1 or 3.9, then the job is not done. Okay, fine. As there is destructive interference, the light will be reflected. The speed is same, distance is same, so time will also be same. Am I right? Speed, distance, time. They will come back at the same time. As there is a phase difference, there will be destructive interference. and there will be no detection. This is photodetector. There will be no detection of light. When no detection, no gravitational wave. What is the feature? I hope things are making sense. This is a bit technical. See, what is the feature of gravitational wave? The feature of gravitational wave is like this. Just imagine you are having a football and filled with air in this case. You are pressing that ball. So obviously when you are pressing in one direction, the radius will reduce. Am I right? And in a direction perpendicular to that, the radius will increase. Yes or no? Same thing happens with gravitational waves. The direction in which they are traveling, in that direction, Earth will be slightly elongated. Slightly means few centimeters, or even millimeters. And in the direction perpendicular to that, it will be slightly compressed. That's why these two arms are at right angle. If it is traveling in this direction, then the length of this arm will be slightly elongated. Am I right? Yes or no? And the length of this arm will be slightly compressed. Now in this case, speed is same, but the distance is not same. Speed of what? Speed of light. Is it okay? Okay. When the distance is not same, obviously this is covering bit more distance. This is covering bit less distance. So this ray will be reflected earlier. It will reach at the destination earlier, and this one will miss the bus. So obviously that's again. So what will happen? There will be no destructive interference. When no destructive interference, this light will be detected at here. That is how LIGO works. I'm repeating. Some of you are staring at me. Listen here. What they wanted to do? They wanted to detect gravitational waves. How? By using the principle of interference. For what is the case? What is the requirement? L-shaped. Why L-shaped has been used? First, this is the question you have to ask me. L-shaped, they could have taken H also. No. And no. The arms have to be perpendicular. Why? Because if a gravitational wave is traveling in one direction, then in a direction perpendicular to that, there will be slight compression, and the direction in which it is moving, there will be slight elongation. That's why it has always to be perpendicular to each other. Is this clear? First, why they have to keep the length same? They have to keep the length same because if there is no gravitational wave, no, means no change in the length. Yes or no? That means the light will come back at the same time. Because distance is same, speed is same, the time is also going to be same. Then there will be destructive interference, you will not observe any activity here. But because of, say, gravitational wave, this arm got increased by delta L, and there was reduction of delta L over here. This is it. I think I've done my job. Here the light will travel a bit more distance. Here it will travel less distance. So obviously this one will be reflected first. It will arrive at the destination first. But this one is not here, so there will be no destructive interference. For that, overlapping must have two things. The second one is not there, it is late. Why? Because it is traveling greater distance. So obviously what will happen? No interference, and you will feel it. That is how the LIGO works. That is laser interferometer gravitational wave observatory. In the worst case, he will be asking the principle behind the working of LIGO, and just search one word over there, that is interference. Okay, that's it. Now obviously you can handle any question as far as preliminary is concerned. Okay, can we take down? Yes. Yamanaka genes. Yamanaka genes. Yamanaka genes are linked with induced pluripotent P-L-U-R-I-P-O-T-E-N-T, induced pluripotent stem cells. In IPSC, the specialized the specialized cells are transformed into unspecialized pluripotent stem cells. Unspecialized pluripotent stem cells. Full stop. For this work, John Gurdon, G-U-R-D-O-N, John Gurdon, and Shinya Yamanaka, spelling. Shinya Yamanaka were awarded Nobel Prize in Medicine. Nobel Prize in Medicine. Nobel Prize in Medicine. Continue. The significance of this research is the significance of this research is that without using embryonic stem cells, remember this word, without using embryonic stem cells, tissues or organs could be developed in the lab. The Yamanaka genes were manipulated in this research. In short, they are depicted as, depicted as OSKM. Full stop. All right, Lego India. And now one more simple question: why that place in Hingoli is being chosen for this project? Because that surface is flat, so you need to have a flat surface. Okay, so all right, it is coming up at Aundh, A-U-N-D-H, Aundh. It is coming up at Aundh, A-U-N-D-H, Aundh, in Hingoli district, Maharashtra. In Hingoli district, Maharashtra. This place has been chosen because the surface is flat. Surface is flat. It is going to be established jointly by Department of Atomic Energy, Department of Atomic Energy, not Science and Technology. Okay, Department of Atomic Energy and National Science Foundation, obviously US. It is the third LIGO in the world. It is the third LIGO in world. First outside US. First outside US. In US, the two LIGOs are at, in US, two LIGOs are at Hanford near Washington, Hanford near Washington, and Livingston. Livingston where? Louisiana. Livingston where? Louisiana. 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 Livingston where? Louisiana. Continue. There are two L-shaped arms. There are two L-shaped arms, each having length of 4 kilometers. 4 kilometers. Each having length of 4 kilometers. At their intersection, this is the intersection. At their intersection, a beam splitter is placed. A beam splitter is placed. Beam splitter is placed. The lasers are released in a manner that they undergo destructive interference. Destructive interference. Destructive spelling. Destructive spelling. Okay. The property of gravitational waves is that the direction in which they travel, there is slight elongation. There is slight elongation. And the direction perpendicular to the propagation of the gravitational waves. Perpendicular to the propagation of the gravitational waves. There is a slight compression. There is a slight compression. There is a slight compression. As a result, the length of the arms will be disturbed, is disturbed, don't write will be. As a result, the length of the arms is disturbed. That means the reflected lasers, that means the reflected lasers will not arrive at the intersection point exactly at the same time, exactly at the same time. Exactly at the same time. Therefore, there will be no destructive interference. There will be no interference. There will be detection of light waves. There will be detection of light waves at by the photo detector, by the photo detector. Full stop. Next. Yes. No difference. Same. Rather, because that is going to be replica. That's why I have made you to write third LIGO. Because those in Italy, in Japan and Germany, they are not named as LIGO. They are named as Geo and Tama. Okay. So there, obviously, the principle wise, they are a bit different. We are not going into this because then it will become open-ended session. So that's where same, exact same principle. Okay, no difference at all.
So in case of are you able to produce
Current scenario, obviously, there are so many developments which have taken place. Like they have developed retina in the lab. They have developed even so many other cells, like some kidney cells they have been able to obtain from that. So there are so many examples of it. But human transplantation, only retina there is. Okay, fine. The next is Aditya. Aditya name is L1. Why it is? What is L stand for? Lagrangian point. Lagrangian points. How it will be launched? PSLV or GSLV? PSLV XL. If PSLV XL is used, then the payload should be less than 1800, or you can say in the range 1800 to 2000 kilogram. So you will not take anything beyond 2000 kilogram when it comes to Aditya L1. See, earlier it was Aditya 1. It was supposed to be there in low Earth orbit. Now we are going to take it 1.4 million kilometer from Earth surface. Okay. And obviously there is something known as Sun. You are laughing. And then obviously there is Earth. And Sun and Earth have got 5 Lagrangian points. Sun and Earth system has got 5 Lagrangian points. If you will draw the circle, Earth will be forming one of the points over here. Okay, so here actually, this is L1. Sorry, L1 is here, L2 here. And this distance is same, 1.4 million kilometer, 1.4 million kilometer. This one is L3, Lagrangian. So obviously, what's the distance? Distance between Earth and Sun, obviously because this is the radius part. Okay, Fourth and the fifth Lagrangian points are here. This is L4, these are L5. These two are more stable, this one and this one. They will be the one, they will be used as parking slots in future. Because once you place over there, there's no, because here, once this because of any reason, there is some disturbance, obviously you will not be able to stop it either that way or this way, it will be eventually collapsing. So what is Lagrangian point? Lagrangian point, actually this is where halo orbit will be. Halo orbit, don't imagine that it will be moving this way. No, it will be moving this way. Around that particular point, it will be. What is the advantage of placing Aditya L1 over Lagrangian points? The advantage is it will be having an unobstructed view of sun always. There will be no impact of any eclipse because nothing will come between here and here. Are getting my point? So that's the advantage. Okay, fine. L2 will be used by James Webb telescope, which is going to be launched next year. Okay, a replacement of what? Hubble telescope. And they say James Webb is going to be 100 times more powerful than the Hubble telescope. So that means we are going to have much more things to be discussed over here. Just one more point about Aditya L1. Aditya L1 will study all the three portions of the sun, that is photosphere, corona, as well as the chromosphere. That's one point. Just remember these three. Okay, what is Lagrangian point? The Lagrangian point is the one where the gravity of the sun and earth or any two heavier objects is balanced by the movement of the other object. That is what we call as Lagrangian points. Okay, this is Aditya L1. Just one more small point. CERN, CERN. India has become the associate member. Last year they asked a question on ITER. Okay, now this year in all likelihood they might be going for CERN. Just brief recapitulation, I am not be going to spend much of a time. CERN, you know, what is the model they are working on? Please come on. They are working on standard model of physics. And standard model of physics, what are the areas they are working on? Please come on. Origin of mass, dark matter and dark energy. And no, not antimatter. What happened to antimatter? Okay. We were always involved with CERN in one or the other capacity. Now we have been given the status of associate member. And who else is there as the associate member in CERN? Pakistan is also there. Iran, no, don't laugh it off. See, that's the problem. We try to laugh off the things. You know what? There's a physicist of Pakistan who has contributed probably the biggest thing in the standard model of physics. So physicists, obviously, like they also have some bright chaps working for them. So that's why Pakistan is there already. Turkey is also there. Iran is also there. And obviously India is also there. Okay. So what exactly we will be able to do? Obviously, first and foremost, our industry will benefit. Most of the people will not take it as the option. Oh, that is a question of science and technology. Industry means commerce. No, obviously in this type, you need instruments and all. And obviously there are some organizations which are specialized in developing that type of instruments. That's the first point. Second point is our people means our scientists will have access to the complete database which the Large Hadron Collider experiment has generated in almost a decade time. Where it will be used, obviously we also have some setups like Raja Ramanna Center for Advanced Technology, Variable Energy that is Cyclotron Center, then obviously Saha Institute of Nuclear Physics, Institute of Plasma Research, Institute of Mathematical Sciences. These are the places who are going to benefit. And one more point is this, our scientists will be recruited full-time to work over there. So if some of you are having the aspiration of doing PhD in physics and looking to work over there, obviously now you have the opportunity to work over there. These are the benefits CERN membership brings to India. Okay, remember, and what they are working on is standard models. What? Mass origin. For mass origin, what's the target? Higgs boson. dark matter, dark energy, and obviously what happened to antimatter. One more possible, please allow me. One more point I would like to specify, just point I will specify. Like Indian Neutrino Observatory. If I have to frame a question, and I will definitely love that UPSC we should bring down the cutoffs. Because good students are getting eliminated when these questions. Now, if I will be asking a question of Indian Neutrino Observatory, whether Indian Neutrino Observatory is working only on neutrinos or is it working on something else as well? Come on. It is working on something else. What something else is? Dark matter. And here you get the membership, associate membership of CERN. So obviously, don't you think that Indian Neutrino Observatory will be the beneficiary? This is where obviously very intricate type of question. The associate membership of India for CERN will have a direct positive implication for which of the following projects? One of them is Indian Neutrino Observatory. Yes, that's true. Because it is working on a standard model, and in standard model has included neutrinos. One more possible question on Indian Neutrino Observatory is, I hope you have been able to establish that link. One more, is it working only on neutrinos? No, what else? Dark matter, dark matter, dark matter, dark matter. Because what is dark matter? Dark matter is something which is invisible, but exerts gravitational influence because of mass. And these two things are there in neutrino as well. It doesn't have charge but have mass. And in your copies, whether this batch, that batch, or that batch, whichever batch, I made you to write ice cube experiment. Ice cube experiment, what was the purpose? In Antarctica, they were hunting for a sterile neutrino. S-T-E-R-I-L-E, sterile neutrino. And sterile neutrino was hunted for its possible role in dark matter. So neutrino research will have the implications for what? Dark matter as well. What are the practical sides of neutrino? It is there in your copy. Earthquakes, telecommunication, nuclear proliferation. इस तरह से तैयारी करिए आप लोग. In a day or two or 3 days, our classes will be over. Don't passively read the newspaper. Okay, अभी आप लोग शताब्दी की तरह चल रहे हो. No, be like passenger train. Whatever you are covering, it should be consolidated. Rather than doing all the things and then always having that lack of confidence. आप सब पढ़ा हुआ है. You have read all these things. There is not even a single thing. I have not invented it. I have taken it from the same source you are all. But what I do and what you people don't do is I spend time on that topic. I don't read passively from the newspaper. I link it with the other topics so that I get first I need to understand it. Then only I can explain it to you. So just imagine that tomorrow you have to take class for that. So obviously your involvement will be that much higher and you will be able to understand things. It is not rocket science, it's very simple. Keep the applied portion in mind. You will sail through the exam. Okay, fine. Now take down. Aditya L1. Aditya L1. Aditya L1 will be India's solar observatory. It will be India's solar observatory. It will be launched by using PSLV XL. PSLV XL. It will be placed at L1 or Lagrangian points. L1 or Lagrangian points. Lagrangian. Lagrangian point. There are 5 Lagrangian points. There are 5 Lagrangian points in Earth Sun system, in Earth Sun system, L1 and L2 are at a distance of are at a distance of 1.4 million kilometer. 1.4 million kilometer. But L4 and L5 are comparatively stable, but L4 and L5 are comparatively stable. Comparatively stable. The advantage of placing Aditya at L1 is the advantage of placing Aditya at L1 is that it will have unobstructed view of sun. It will have unobstructed view of sun. There will be no eclipse. There will be no eclipse. L2 will be used for placing future telescopes. Now, right? Associate membership of CERN for India. Associate membership of CERN for India. CERN is a European lab. CERN is European organization. Don't write lab. Is a European organization conducting world's biggest experiment. In particle physics. In the form of Large Hadron Collider. In the form of Large Hadron Collider, HADRON, Hadron Collider. LHC is looking to find answers. LHC is looking to find answers of the following questions. First, origin of mass. Second, dark matter and dark energy. Third, what happened to antimatter? Full stop. The benefits arising from the associate membership, the benefits arising from the associate membership are: first, opportunities for industries to participate. Opportunities for industries to participate. Second, Indian scientists can participate in all experiments. Indian scientists can participate in all experiments. There will be unrestricted access to the data. There will be unrestricted access to the data. There will be unrestricted access to the data. The other associate members are Turkey, Ukraine is also there, Pakistan, Turkey, Ukraine, Pakistan. Full stop. Iran, I haven't come across. If it is, okay, I'll cross check, then let you know. Right now, I'm not sure about Iran. I have not read it. Okay, I might have missed, but I haven't read it. Okay. Now, next is G protein coupled receptors. GPCR, G protein coupled receptors. Listen here, it was in news because of IIT Chennai and all that. In that Education Plus Monday section, it was there. See, what is G protein? Just remember here, most of the pain we had, most of the action of the hormones we have in our body, and almost half of the medicines we take, remember this, they work through this mechanism. That's why I'm discussing. Okay, almost half of the medicines use this principle, irrespective, especially blood pressure, diabetic type of medicine. Actually, what is G protein? See, if this is the surface of cell, this is the cell membrane, G proteins are embedded proteins, means a part of them is here, then a part of them is within the membrane, and a part is obviously protruding inside the cell. So especially the anti-diabetic or anti-blood pressure medicines, they are not entering inside the cell. No, don't imagine that medicine is going inside the cell. That chemical of that medicine, they come and attach with the G protein over here. And once this chemical gets attached with the G protein, same thing is with hormone. Hormone is also a chemical. Okay, so that. Then once it is attached with this chemical over here, the protein inside is obviously made to undergo the changes. Okay, coupled. Coupled means what? Linked, isn't it? Coupled, and receptor obviously has to be outside because it is receiving the chemicals. And as a result, it introduces the desired changes in the cell. Sometime obviously blood pressure is there. Blood pressure is linked to some hormones in the body which are being generated. Okay, fine. So that way they block the process of the formation of those hormones. Same is the case with diabetes. Diabetes, what happened? The plasma membrane is not in a position to utilize that carbohydrates, that insulin and all. So they induce these changes. That is what we call as G protein coupled receptor. 2 lines I will be dictating on it. Please take down. G protein coupled receptor. Majority of the medicines and the hormones in the body work through this mechanism. G protein is found on the surface of the cells. G protein is found on the surface of the cells, is found on the surface of the cells. A part of it is embedded in the plasma membrane. A part of it is embedded in the plasma membrane. And the remaining portion is protruding inside the cell. And the remaining portion is protruding inside the cell. Inside the cell. Protrude means projected in the cell. Continue further. When the chemicals, whether hormone or the drug, are being taken by the person, G protein binds with them, and induce the desired changes in the inner proteins. So that the physiological effects take place. Full stop. What you need to remember? Hormonal action, drug action. What is GPCR? A protein. That's it. Next. IIT Madras, they have worked out an easier method of doing this. Okay, that will not go. Okay, now listen here. Phyllae rosetta. What is the purpose of phyllae? Match the column type of a question, although they are not asking. Comet. Which comet? 67P. What's the other name? Churyumov-Gerasimenko. Got the name? Okay. Why it was in news? This project is over or started? Finished. It's finished. Of whom? NASA? European Space Agency. What is the difference between Phyllae and Rosetta? Rosetta, orbiter, and Phyllae, lander. Okay. But then it has been like, when it was launched? Come on. 2004 by European Space Agency to study the comet. Which comet? 67P or Churyumov-Gerasimenko. It reached there. Where? Comet. Which comet? I'm saying it for the next time. Okay. And again remember comet. Osiris Rex, asteroids. Okay. New Horizon, Pluto. Okay. This type of things you have to, I know it will get a bit confusing, but you have to do it. Okay, fine. What happened? Like, let me dramatize it a bit so that you can remember. Okay. See, Rosetta reached there in 2014. Where? That comet. It's not easy to pronounce it again and again. So, that comet. And when it was launched, 2004, it took 10 years. And just one point I will make. Like India has specialized this technique we call as low energy transfer. Like we have discussed, like Mars orbiter mission. First it was placed in Earth-centric orbit, then we take it to Sun-centric orbit, then we take it to Martian orbit. Whereas US and European agency, they go for a straight path. Like Marvin, I'm just drawing analogy. Marvin was reached there 22nd September. We reached there on 24th September. How Marvin is different? I'm just giving you the analogy. Marvin was not going like this is Earth, then Sun, and then Mars this way. No, simple straight. This requires very higher quantities of energy. And here you are simply manipulating the momentum. So European Space Agency followed this approach. It was not low energy transfer. Marvin was also not low energy transfer. Just remind me, just 2 minutes I will be spending over there after this topic. What happened? Rosetta reached over there 2014. Philae separated from the orbiter. Okay. And it was having a tripod like this tripod you are having. It was supposed to land exactly this way. But somehow it got tilted. And when it tilted, it landed this way. And its solar panels got in a direction opposite to that of Sun. And obviously, as a result, when solar energy was not there, and means solar panels were not getting the required quantity, there was no electricity. So obviously, Philae decided to go into hibernation, which some people do in the class as well. Hibernation, because lack of solar energy. That is the case. But obviously from there itself, obituary was written about it. There is no viability. But later on, somehow, some bit of this thing, solar energy was received, and because of that, the batteries got charged for some time, but again got discharged. The problem is now this comet was moving away from the Sun, and now as it was moving away from the Sun, you have to be practical. That is science. There is no possibility of increased solar insolation. Rather, the insolation will keep on decreasing. So they thought there is no viability. So later on, what they did, they have crashed Rosetta onto the surface of that comet, because Philae was already there. Rosetta has been crashed, not Philae. And with this mission has been closed. They were looking to study that comet. That is what we call a 67P. Or you say that at least by looking at it, you will be able to identify Churyumov-Gerasimenko. Oh, this was the name we were hearing in the class, and take it and move on. Now, just one point just listen to me. If, say, for example, you get this question, because ExoMars mission is in news. ExoMars we have discussed. Like, say, for example, they will give you 3 missions. One is MOM, second is Marvin. Marvin is of NASA, and third one is ExoMars mission. Okay, here one possibility of a question is, of the 3, the human transfer or low energy transfer was used by MOM and ExoMars. ExoMars is the first because it has been there in January 2016. This one reached. ExoMars is the first after Mars orbiter mission to follow the same principle of transportation as done by Mars orbiter mission. And that is what we call as low energy transfer. Low energy transfer means first it was placed in Earth-centric orbit, then it was transferred in a Sun-centric orbit, then from there it is taken to the Martian orbit. Whereas in case of Marvin, they have gone for this straight approach. Is this clear? Okay. This again, same thing I am saying, is specificity. This much clarity you have to develop. Then 65-70 question will not be a tough thing to achieve. Okay, now please take down. Philae and Rosetta. Philae Rosetta. It was a comet mission, comet, C-O-M-E-T, comet mission of European Space Agency. It was a comet mission of European Space Agency, launched in 2004. And reached the comet 67P 67p or to remove Gerasimenko. In 2014, Rosetta is an orbiter. Remember this? Rosetta is an orbiter, double T. Rosetta is an orbiter, and Philae was a lander. Philae was a lander. Philae, Philae was a lander. The landing of Philae was not perfect. The landing of Philae was not perfect. As a result, the solar panels were not receiving. As a result, the solar panels were not receiving enough sunlight that is why Philae went into hibernation. That is why Philae went into hibernation. In between, it became active for some time. In between, it became active for some time. But the comet was moving away from sun, Therefore, the possibility of the revival were less. That is why Rosetta, I am again emphasizing, Rosetta was crashed. On the surface, and the mission has been called off. What? Called off. Full stop. Next point is this. What was the topic? Just forgot the topic. No issue. Like just take down. I'm trying to recall the topic. What exactly was there? Like Hohmann energy transfer. HOHMANN. Hohmann energy transfer. It is also known as low energy transfer It is also known as low energy transfer. This mode has been used by ISRO. This mode has been used by ISRO to place the satellites in the orbit. To place the satellites in the orbit. As well as for carrying, as well as for carrying the, Mars orbiter mission. The ExoMars mission of Russia, the ExoMars mission of Russia, ExoMars mission of Russia, and European Space Agency has also followed the same mode of transportation, same mode of transportation. Whereas MAVEN, M-A-V-E-N, what is the purpose of MAVEN? Come on. Outer atmosphere. What is going on in the outer atmosphere of Mars? Erosion. Okay. Whereas MAVEN of NASA was taken to Mars in a direct mode. That requires comparatively more energy. NASA is using the same approach for placing the satellites as well. Full stop. Today I will take only this much, to be honest. Without preparation, I don't discuss any topic. So this was my zakhira, because yesterday I was trapped somewhere, so I got very less time to really brush them up. So there was some tragedy actually. So tomorrow we'll continue. Listen here. This science tech, then environment portion. Environment portion, like the pollution related, like municipal solid waste, e-waste, transboundary movement, POPs, air quality index, that Bharat stage related controversies, the technologies and all. I think that is more probable area. First, let me complete this. IT related, some topics are left. Okay, like dark sky reserve and all these type of projects. I'm sure we will be able to cover the questions. Okay, so tomorrow 8:30 I will be in class. Okay, and obviously tomorrow we will be able to finish off this environment. Day after tomorrow, like my assessment is some 4 or 5 questions they will be asking on IR also. Like last year they asked some questions. So organization based and all that. Organization based, he will simply give you the stuff, this organization, this job, and we are a bit of a like this foundational agreement, BACA, LEMOA, SISMOA, okay, this DTTI, this type of thing we will do in the class. So 1 or 2 questions like aircraft carrier, where US will be able to participate and all that. Like chemical weapons, okay, sarin, which has been used, how it is different, nerve agent, how they are different from blood agents, and how blood agents differ from blistering agents. So if we can cover up to this level nowadays, obviously then you will be rest assured that we will get the question done. Okay,